In today's note, we are going to be looking further at linear relationships. So we're going to carry over the ideas from the previous lessons, and again look at different examples or different scenarios that we may come across, just to show that the steps are basically the same. So to recall, to determine the slope of a linear relationship, basically we are finding the rate of change for every step in the relationship. Right, so we talked about, so for every step or every increase in step or position number, we're looking for the increase in tile numbers. Same idea, that is the very basic core idea of the entire rate of change. In order to do this, we need to look at how the y values change with respect to how the x values change. So again, we talked about m being the change in y over the change in x. So that's the formula that we talked about. In previous examples, in most cases, the x value has always been 1, or the change in x values have always been 1. I think there was one example that we may have looked at in a previous lesson where that wasn't the case, but in most cases, the change has always been 1. So basically we found how the y values changed at each step, and that was our slope. But if we're given a pattern where the change in y values is other than 1 or something other than 1, that's where we have to really rely on this formula. Right? So when we were looking at the patterns, it was always increasing by 1 step, so we could always look for the multiplier, the rate of change, just by counting how we changed from each step. But if we're not given that increase of 1, we need to look at this formula. So for example 1, an example of inconsistent increase, because if we look at the x values, they're not all increasing by 1. The idea is still going to be the same. I want to find my slope from this table, or my rate of change. So I need to look for the change in y values, and in this case we should see that we are increasing by 15, then by 20, and then by 40. And if I look at the x values, I can see in the first step, or the first one, they increase by 3, then they increase by 4, and then they increase by 8. So here I have 3 different scenarios or possibilities for finding my slope, because I have 3 different changes to look at, or pairs of changes to look at. If I look at the first one, plus 3 for the x and plus 15 for the y, if I go back to my m, or my slope formula, the change in y is 15 over the change in x is 3. This can be reduced or simplified to 5. If I look at the next pair of points, I can see that for my m value, the change in y is 20 over 4, which also equals 5. And then finally, as well, if I'm looking at the last one, the change in y is 40 over the change in x, which is 8, which also equals 5. So basically, regardless of which two points I use or which change I look at, again, as long as they're paired up, the slope should be the same, especially for it being a linear relationship. So basically what this means, I can see that for every change in y in 15, the change in x is 3. I reduced all of these different examples to 5. So basically that m of 5 means that a change in y of 5 every time x changes by 1. So that means y changes, or there's a change in y of 5 every time x changes by 1. So if we're to look at another example, same idea. See, what does the change or happen to be a change in y. Here we have some numbers where it might be harder to count. So what we want to do, we can just do 75 minus 17 to see what that change is. And again, we should see 58. We do the next one. Again, harder to see the change, but I can do an operation or some calculations. So 223 minus 75. And I can see that the change is 148. Here, we're actually getting smaller. I can still figure out the change by doing negative 3 minus 223. So that same idea. In this case, my change is going to be negative, which is fine because that means basically that I'm just going down. In this case, I'm going down 226. And if I look at the x's, I'm increasing by 29, increasing by 74. And here, again, because we know this one we're going down, it's a decrease or minus 113. So again, it's okay to have a change that's minus, that's just basically, or negative, that just basically means that we're decreasing. If I want to find my m value, again, I have three pairs of changes to look at. If I look at the first one, m equals, again, the change in y. Let me write that above again. M equals change in y over change in x. So for the first pair, 58 over 29, this can be reduced to 2. If I look at another pair, or the next pair, m equals 148 over 74, which I can reduce to 2. And finally, the last one, m equals negative 226 over negative 113, which also reduces to 2. So again, if it's a linear relationship, we should be finding that the slope is the same regardless of which 2 points we use. You don't need to go through and do this 3 different times. If we're given the table and we're told it's linear, all you need to do is pick 2 points, find the change in y, and find the change in x, and that will be your slope. So, taking that idea, let's put this into a word problem. So Haley has 3,000 points in a game she plays. Every turn uses up 50 points. We would first want to model this relationship with an equation. So the 2 key things that we should be looking or highlighting or underlining, she has 3,000 points and every turn uses up 50 points. I want to come up with a table of values to help me visualize this problem. You may be able to do this already without using the table because of what we talked about with word problems in a previous lesson. But I want to come up with what my independent variable is and what my dependent variable is, or again, what my x and what my y are. And in this case, again, this is where the dependency statement can come into play. So what depends on the other? And the 2 variables that we have are the number of turns and the amount of points. So does the number of turns depend on the number of points, or does the number of points she has depend on the number of turns? What we should find is the number of turns is independent and the number of points is dependent. So using this, we can come up with our table of values. If she starts the game with 3,000 points, that means after 0 turns, she has 3,000 points. After 1 turn, we lose 50 points, or we use up 50 points. So therefore, our total number is 2,950. Number 2, or 2 turns, we go down by 50 again. 3 turns, we go down by another 50. Now that I have my table of values, I can come up with my change in y and my change in x to help find my slope. So here we can see that we're decreasing by 50 for the y every time, and we're increasing by 1 for our change in x. So that means that my m value has to be minus 50 over 1, or just minus 50, right? Change in y over change in x. If you're comfortable with word problems, you might have already recognized that from the scenario, using up 50 points. So using up would indicate decreasing, so decreasing 50 points or decreasing 50 per turn, or for every one step. The b value, which we need to figure out, is when x equals 0, or my starting or initial value. From the table, I can easily see that. So I can see that my b value is going to be 3,000. Or if we know the other terms, 3,000, the initial value, starting point. So our starting point is 3,000. You may have also picked that up from the word problem itself. So that means our overall equation is going to be y equals negative 50x plus 3,000. So again, you can use the table. I would say if you have trouble visualizing the scenario, I would say definitely put it into a table, because then it becomes kind of a step-by-step pattern of what we have to do. Find the change in y, find the change in x. That will help you find your slope. Look for when x equals 0. That will be your y-intercept, or your b value. The second part asks how long until Haley runs out of points. So this one might be a little bit more difficult, but we can use the table of values if we wanted to and keep on going down number of turns, increasing by 1 by 1 by 1 until we get 0 points. Or another way we can think of it is when she runs out of points, that's basically saying that y equals 0. And what does x equal? How many turns will it take for us to get a y value of 0? Since we have an equation, y equals negative 50x plus 3,000, I know one of the values that I want to find, right? Remember, x and y represent any number of scenarios where we have turns and points. I have one scenario when I have 0 points, and I want to know how many turns is that going to be. So I'm going to take this value of y equals 0 and plug it into the equation. Now what I'm left with an equation that I can solve for. I can solve for x now because I only have one variable. So going back to solving equations, I'm going to minus the 3,000 from one side, minus it from the other. One side cancels out. I have minus 3,000 equals negative 50x. I'm going to divide by negative 50 on the one side, divide by negative 50 on the other. One side will cancel out, and I'm left with x equals 60. So I plugged in one value, and I solved for the other, and I got that x equals 60. So therefore, it will take Haley 60 turns to run out of points. And again, you could have reasoned through that in another way. You could have just recognized, well, I have 3,000 points. Every turn uses up 50, so you could do 3,000 divided by 50, and that would give you your number of turns. If that wasn't quite clear, you can always rely on the equation to help you figure that out. And the equation can be used for many other things, regardless of, or not just finding when you run out of points. You can find out how many points am I going to have at 50 turns, right? So you plug in 50 for x and solve for y. If I want to know how many turns will it take me to get to 1,000 points, we'll plug in 1,000 for y and solve for x. So you can solve for any number of points or any number of turns using that equation. The next example is going to be a negative slope. So the only scenario here, the only thing that's changing is just what our slope's going to be. We have a table of values. We kind of know the steps by now. Find the change in y, find the change in x, and see what we get. So we can see that the y value is decreasing, in this case by 100. In the next one we decrease by 800, so minus 800. And the next one we decrease by 3,000. On the x side, here we're increasing by 5, increasing by 40, and increasing by 150. So make that a little bit nicer. So increasing by 5, increasing by 40, increasing by 150. Again, we should know that it doesn't matter which pair we use, we will always get the same as long as it's linear. And in this case, for right now, all the equations or all the relationships will be linear. So again, do that change in y over change in x, negative 100 over 5, and we get negative 20. Again, you could use the other pair, negative 800 over 40 also equals negative 20. Again, finally, you could also use the last pair, m equals negative 3,000 over positive 150, also equals negative 20. Let's say, for example, we should be fairly familiar on how to find the slope by now. What if we wanted to find the equation or the b value? Right? What if we wanted to find y equals mx plus b? Right? I wanted to know what that equation is. I know the first part. I know it has to be y equals 20x. But what's my b value going to be? I don't see it on this table. I don't have a graph. I don't have an equation that I can look at. I don't have a scenario. We can use the understanding that if I go back 5 spots, I know how much it should increase by, because at 5 spots it changes by negative 100. So going back the other way, I have to add 100. That means I'd end up at 0 and 1100. Additionally, because we know what the slope is, we could go through and say, okay, if I go back 4 to 4, that means I have to go back 20, right? Because for every change, increase in 1 by 1 in x, it's a decrease in y by 20. So if I decrease the y by 1, that means I have to do the opposite and increase the y by 20, and you can work your way back, or you could use the idea of that first change that we see there. So then that means my equation would be plus 1100. Again, if I'm looking for the negative slope and I have a graph, we want to basically pick out points where the grid line or where the grid lines cross. Luckily for us, we're given 3 points that do cross nicely. If we wanted to, there are a few other points that we could use as well. But again, I'm just going to pick at least the 3 that were given, maybe one more because we have the extra space. So for the first one, we have 0 for x, 1 for y. The next one is 1 and negative 2. Third one is 2, negative 5. And then lastly, 3, negative 8. Again, I want to find the change in y and the change in x. Here it's nice because the change in y is all the same, so minus 3, minus 3, minus 3, and the change in x is all the same as well. It's plus 1, plus 1, plus 1. So my m value, or again, change in y over change in x, just to remind ourselves, is equal to negative 3 over 1. So for every increase in one step, or every change in x by 1, our y value decreases by 3. Or for every change in y by minus 3, our change in x is by plus 1. For the b value, there are two ways, again, we can find it. From the table when x equals 0, or from the graph, we go down our y-axis and see where do we hit that line. So that means our b value is equal to 1. And that will help us come up with our equation of a line, because we have our m and our b value. So our equation is y equals negative 3. You could say 3 over 1, or you could just say minus 3x plus b. And that's our equation of a line. Now what we can do is we can also see that a negative slope decreases going down and to the left, or sorry, down and to the right. So as we go over to the right, our graph is going down. And we can see by our slope, although we did have that 1 point filled in, but we can see that every increase in 1x, we decreased by 3 to get to that point. And we can see that pattern true for all of them. Right? We increase by 1x, we decrease by 3. Increase by 1x, decrease by 3. So again, that's just another way of where we can see our slope. But as long as we can find the points and come up with a table of value, that's the key thing. In example 6, here we're going to come across a scenario where our slope is going to be a fraction. We want to determine an equation of a line represented by the points on the table. The steps are going to be the same. Find the change in y, find the change in x, find the b value, and plug it into y equals mx plus b. So, first thing I'm going to do, I already have my table. Let's find our change in y and our change in x. So m equals, again, change in y or change in x. You may also see it as a triangle y and a triangle x. That's just, triangle represents the Greek letter delta. So delta y over delta x just means change in y over change in x. So if I look at the y's, I should see that I'm increasing by 2. If I look at the x's, I'm increasing by 3. So that means my slope, or my m value, is going to be 2 over 3. Again, that's fine. We base it off of it. So that means for every change in y by 2, the change in x is 3. This is our slope though. So I have my m value. Now I need to figure out my b value. How do I find out my b value? Well, we should know, or because we're increasing by 3, we can work our way backwards, where if I go back to 0, or if I go back 3 steps, that means I have to go back 2 in the y, which means I would go to 1. So if I had minus 2 and minus 3, or basically I'm doing the opposite pattern. If I'm going down my table, I'm increasing by 2 and increasing by 3. If I go back, I'm decreasing by 3 and decreasing by 2, which will give me my y-intercept, or my b value. So in this case, b equals 1. Oops, forgot to change in the last one. That should actually be a 1. So if I put this all together, y equals 2 over 3x plus 1. This is my equation of the line. example 7, slope as a fraction. Here I'm given a table and a graph. So from my graph, I'm going to plug in my points. Right, I've already given some nice points where they nicely cross the grid line, so I'm going to use those. First one is -8 and 0, and 0 and 2, 8 and 4. I do have some other points that I can see in here as well, but I'm going to stick to the ones that are already labeled for me or clearly identified. That way, even if I'm slightly off, I know that, or if these points are slightly off, I know that the ones I used are nice points. So again, we're trying to find that change in y and change in x. Here our change in y is +2. Our change in x is +8. So my m value is going to be 2/8, which I can reduce to 1/4. And this 1/4 is actually going to be where these other points are. So these other points in green that I labeled here are actually nice, because if I increase by 4 and increase by 1, or change the y by 1, if I do the same thing from this point, I change the x by 4, change the y by 1, I can see that that's where those points nicely are. So I know my b value, or sorry, my m value. If I want to find my b value, I find when x equals 0, what is the y value? Or I can go right to my graph and go down the y-axis and see where it crosses. In both cases, it should be the same thing. So the b value in this case is 2. I'm just going to take these two values and plug them into my equation. So 1/4x plus 2 is my equation of this line. Lastly, last example, here I'm given a line, I only see 2 points, or I'm only given 2 points. So I can see the 2 points that are clearly labeled here. I only need to have 2 points to figure out my equation of a line. So if I plug them in, 0, -4, this next one is 2 and 2, I have enough here to find my change in y and change in x, which is +6 and then +2. So m is going to equal 6/2, which also can be reduced to just 3. If I want to find my b value, it's nice because one of those points is my b value. I can see that that's where it crosses the y-axis here. If not though, again, I can use the line to visually see. I also can use the table to see, well, when x equals 0, what is the y value? So I know b equals -4. So in this case, putting it all together, y equals 3x minus 4 is my equation of the line. So really all I need to have are 2 points that are part of the relationship or part of the line, and I can use those values to help me figure out my m. If I'm lucky enough to get the b value, I can just plug that right in, or I can use that slope or that m value to work my way back to when I'm at position 0 or step 0, or when x equals 0. And if I work my way back, then I should be able to figure out what my y value is and use that for my b value. So there's a couple more try this questions to go through, so try to work on those on your own. Bring them up here just in case you're just watching the video and don't have the note. But again, what we looked at in this lesson is basically different scenarios where we have to come up with the slope or come up with the equation of a line, where we're not always going to get that change in x of 1. Right, so we might have a negative slope, or a slope as a fraction, or maybe we just have a variety of points. As long as you have 2 points, you should be able to find the slope, and then from there you can work your way back to find your y-intercept or your starting value.